So in this particular section, we're going to be talking about organizing and visualizing data. This is part of Chapter 14, which focuses on statistics. Statistics is pretty important for understanding the news that you read in the newspaper or in magazines or articles, and for understanding what is presented on television and on the radio. We're going to be talking about the difference between a population and a sample. When surveys are done, they go out and they talk to various people about ideas or opinions, and they bring the data back and they analyze it and try to make predictions about what will happen in the future. This is for statistics, which again is interested in gathering, organizing, analyzing, and making predictions about the future from information that they've gathered, usually from talking to other people. Now, the data that they could gather could be qualitative, as in, do you like this cereal? Do you not like this cereal? Does this taste good to you? Does this not taste good to you? Or it could be quantitative, as in, how many times per month do you go to the movies? So quantitative data is typically a number of some kind, and qualitative data is about opinions such as, do you like something? Do you not like something? It could be something like your eye color or your gender, which way you vote. Those aren't numbers. Those are characteristics. Now, when we talk about the difference between a population and a sample, so you'll be looking here on the sheet that you can see about the population. A population is the set of all the people or things in a particular group. So, for example, if we're talking about the population of college students in the United States, if we want to know something about what college students in the US like to do on weekends, it's not practical for us to go out and interview and talk to every single college student in the United States. So what we do instead is we come up with a sample of college students in the United States, and we ask them about what they want to do on the weekend. And that way we can make predictions about the entire population of all college students in the United States by talking to a subset of those people. So a sample is a subset of the entire population. Now, there are some problems. If the sample that you get is not representative of the population, so this is down here in the first bullet point, then you will not be able to rely on the results. This study is then called biased. So let me give you an example of that. Let's suppose that you want to know something about all of the college students in the United States, but you only go to community colleges in rural areas. If you only go to community colleges in rural areas and talk to those students, what they'd like to do on the weekend may be very different from what community college students in the city like to do. And those students may be very different from what community or college students at four-year colleges and universities like to do. So when you pick your sample, you have to make sure that the people in the sample are just like the entire population. So for example, if your entire population of college students is 55% male, but you only interview females, then you're going to have a biased result. You need to try to balance it according to age. You have to balance it according to gender. You should be balancing it according to sexual orientation. It should be balanced according to race, to ethnicity, to rural versus urban. There are all kinds of considerations that come into play when you pull a sample from the population. The more like the population the sample is, the more reliable your predictions are going to be. Another thing that can bias results from a study are the way you ask the questions or the statements. If the questions that you ask or the statements that you use are confusing to the people that you're addressing it to, they may answer incorrectly, as in they don't give the answer they would have given if they'd understood the question or the statement better. So you have to be careful about that. Let's move on to the next part. In this section, we're talking about frequency tables. Now, a frequency table is one method used to organize data. In a table, you're going to list the values that you can have on the left-hand side in a column, and then the frequencies with which those values occur in a column to the right. We'll also be talking about relative frequency, which is the number of times it occurs out of all the number of people that you asked. So let's talk about different values that you could have. If you're talking about eye color, then the values you could have might be things like blue, brown, black, hazel, green. Those would be the values that would show up in the far left column. Let's suppose that you did a survey of all the college students at Red Rocks Community College, and for your sample, you chose at random 5 different classrooms, and you went into the classrooms and you tried to decide, okay, who has brown eyes, blue eyes, hazel eyes, black eyes, and green eyes. Then you would count up the number of people who have brown eyes, and that would be your frequency. So the value would be brown eyes, and the frequency is the number of people in your sample that had brown eyes. Now let's suppose out of all the classes that you asked, you surveyed 200 students. And let's suppose that of the 200 students, you found that 100 of them had brown eyes. Then your relative frequency would be the number of brown eyes in your sample divided by the total number of students in the sample, or 100 divided by 200, and that would give you a relative frequency of 50%. When you're talking about the values you're looking for, the data values that you're collecting, it can sometimes be the case, especially when they're numeric, that there are just too many different values. For example, if you're going to consider the ages of the people you're surveying, then for college students, the ages could be anywhere from 16, generally speaking, up to 80. And you don't necessarily want to write all that down. So what you might do instead is you might group them into ranges. So you might do something like 0 to 9, where we wouldn't expect to have any college students, 10 to 19, 20 to 21, and so on. Then you have a range, and then you choose all the people that fit in that range, and you make a tick mark for your frequency. And then to find the relative frequency, you divide the frequency by the total number of people in your sample. Let's take a look now at problem number 6, which is at the bottom of this page. In problem number 6, we're going to construct what's called a frequency table and also a relative frequency table, and then later we'll use this information to create a histogram for the data that's given. Now let's take a look and see what kind of data we have. The ages of 40 Executive volunteers who are advising young entrepreneurs is given below. If you scroll and kind of look through all the different ages, and again, the ages here are 51, 56, 57, 52. If we scroll through them, you can see that everyone, it seems to be, who are in the Executive volunteers are all in their 50s. Since they're all in their 50s, there aren't as many ages as if I had to consider from birth to age 80. So I will probably just use each individual age as a value. If I look through my list then, what I need to find next is the smallest value or the minimum and the largest value or the maximum. A quick scan tells me that I don't have any 50-year-olds, but I do have some 51-year-olds. I don't have any 60-year-olds, but I do have a 59-year-old right here. So I'm going to start, and on the left side of the table, I'm going to create a list. So I've got 51-year-olds, I've got 52, 53, 54, 55, 56, 57, 58, and 59. It looks like those are all the data values that I collected. Now I need to know their frequency. So what I'm going to do is I'm going to come over to the frequency, and I'm going to put in a tick mark every time I see one. So I have a 51, that's my first data value. And then going down, I've got, oops, it's making an L, so we don't want that. Let's just make it a 1 instead. That'll be a tick mark for us. Okay, so coming down then, I've got, let's see, a 56, and then I've got a 57, I've got a 52, and so forth. Go ahead and take a few minutes and make tick marks for all of the ones that you see, and then we'll come back and compare our values. Now that you've taken a few minutes to add up your numbers, let's see if we got the same values. I have 3 51-year-olds. Coming down to the next row, looks like I have 7 that are 52. For 53-year-olds, I have 6. Oops, I should put in the equals. And for 54-year-olds, it looks like I've got 5. And for 55, I've got 5. And then I've got 3. And I've got 5 57-year-olds. And I've got 4 58-year-olds and only 2 59-year-olds. Now that I know the frequency with which each of these values occurs, this part here, the first 2 columns, is called a frequency distribution or a frequency table. To find the relative frequency, I need to take the frequency here in the second column and divide by the total number of people that I asked. So below the frequency column, I'm going to add up all those values and put in my total. That's 3 plus 7 plus 6 plus 5 plus 5 plus 3 plus 5 plus 4 plus 2. How many different people did we consult? My total is 40. So to find the relative frequency, what I need to do is divide 3 by 40 and come up with a value for that. Let's fill out the table. You take a few minutes to fill it out yourself, and then we'll come back and compare our values. Here is the completed frequency table or relative frequency table that I have. I have that there were, out of the 40 Execucorps volunteers, 3 of them were age 51, which is a frequency of 0.75 or 7.5%. 7 were 52, 0.175 relative frequency or 17.5%. When you're done, the total of all your frequencies down here at the bottom, you should end up with 40 divided by 40, which should add up to the number 1, which should also add up to 100%. This is a good way to check your relative frequency. Now, if you did have to round off some of the percentage values, you might be off by perhaps 0.1 or maybe even 0.2, but you shouldn't be off by very much. Let's take a look at the next page. On the next page, we are looking at representing data visually. By representing data graphically, we can observe the patterns more easily. You see these whenever you are doing, for example, a pie chart or a bar graph or a histogram. Okay, so now we're going to be taking a look at representing data visually. So here is an example of a bar graph if you're looking right here. And a bar graph basically presents your information or your frequency along a vertical axis, and along the horizontal axis, they're usually divided up into your classes or your data values. So previously, on the previous page, our data values were the ages, and the frequency was how often those ages occurred. So when you're looking at the bar graph, down here you would have the ages, and then on this you would have the frequency with which they occurred. On this particular bar graph, this is a survey of people and what their favorite type of movie is. So the classifications or the values were comedy, action, romance, drama, and sci-fi. So to interpret it, for example, it looks like we had one person whose favorite type of movie was a drama because this bar goes up to the 1 mark. It looks like there were 4 people who preferred comedies, 5 people who preferred action movies, and 6 people who preferred romances. A bar graph is one way to visualize the frequency distribution for qualitative data or quantitative data. When you draw the bar graph, you put the classes or the data values on the horizontal axis and the frequencies on the vertical. The heights of the bars then correspond to the relative frequencies if you're doing a relative frequency distribution. Now, quantitative data, again, can only take on specific values. Those quantitative means numbers, not necessarily the numbers in between them, but maybe you can. For example, your weight, your age, and your height are what we call continuous data, because I could be 5.2 inches, 5.21 inches tall, 5.22 inches tall, or any value in between. That's a continuous quantitative data value. Weight is another continuous quantitative data value. However, the number of children you have is discrete. No one has 1.2 children. They have 1 child, 2 children, 3 children, or 4 children. The number of children you have, or the number of siblings you have, brothers and sisters, that's what we call discrete data. You can have 5 siblings, you can have 4 siblings, but you can't have 4.5 siblings. When we have continuous data, we often will use ranges to represent the data values. So instead of saying weight of 120 pounds, weight 120.1, we'll instead say weight between 120 and 125, weight from 125 to 130, weight from 130 to 135, and so on. When it's continuous, though, we do have a problem. If we're going to divide our weight into 120 to 125, I can't start the next weight range at 126 because there are people who weigh between 125 and 126. So 125 would be the data boundary, and I have to decide whether I put it in the lower group or the upper group. As long as you're clear about it, it's usually okay. Sometimes when you're doing something like that, we might actually list the weight ranges as something like 120 to 125, comma, and then the next range would be 125 plus to 130. Now, what do we mean by this? When we put the plus, it means you can't weigh 125. If you weighed 125, you'd be in the previous group. If you weigh 125, you have to go below, but 125.0001 goes in the next group. You can use the plus or minuses after the number to indicate which group that particular boundary value belongs in. What's the difference between a bar graph and a histogram? A histogram is exactly like a bar graph, but you don't have the spaces in between. So if we don't have spaces in between the bars, then we will need to label the endpoints of the intervals on the axis. So here's an example of a histogram. Let me make it larger so that you can read it a little bit better. And I'll scroll it up. This is a histogram of arrival times per minute. So perhaps this is at an airport or something. Do you see how the bars all connect here? They're side by side and they're touching. Up here on the bar graph, they were separated into distinct groups. Here, the idea is that they could be coming right next to each other. We often use histograms for continuous data, but in fact, you could use histograms for continuous or discrete, and you can use bar graphs for continuous or discrete. It's up to you to decide how to group the data and how wide you want to make each data range to be. You need to make sure, though, that you decide for any boundary value which class it's going to go in. You don't want to count it twice because that will skew your data and bias your results. The next section we're going to talk about is the technology with which we can produce histograms. I have in my notes here 3 different ways for you to produce a histogram. The first one we'll talk about is Desmos. Desmos is an online graphing calculator. You can also use a calculator, a graphing one, or you can use Excel. There are other ways to produce histograms as well, as in addition to doing it by hand. Let's look at how to do it using Desmos. On your computer, to access Desmos, you can click on this link here in your notes. It is a hot link, so if you open it with Word, you can hit the Control key and then click on it, and it should take you directly to the one I want you to use. If you have trouble with that, you can also use Google to find the Desmos histogram creator, and that will also bring up the one we want to use. Let me show you what it looks like on Desmos. On your screen, you should now be able to see both my notes to the left here and the online Desmos histogram creator. If you look here, you'll see that there is a folder and a triangle right here next to the words data and bins. According to the notes, you want to make sure that this data and bins triangle is down. If it's not, you'll need to click on it. Watch what happens when I click on it. If I click on it, it closes and now the triangle is sideways. So you want it to be facing down so that you can access the data points. When we're looking at this, you'll see that it does explain in every other line what the next line does. N is the number of the value, but it has no meaning for our histogram. You can ignore all the values that are here in this N line. These values that are over here in the V line, this is where you're going to enter your data values. You will be able to double click on them and that should highlight it, or you can use your cursor to highlight it. We want to enter in some of our data values. If we're looking here, let's scroll up to where we had our histogram frequency distribution for the ExecuCorps volunteers. What I want to do is I want to put in my different frequencies. So on this one, I need to put in how many times I had that particular value. So in this case, what would I do here? In order to get the frequency distribution, I need to enter in the data values. So where you see this list up here, we're going to enter those values for the second column on Desmos. So the first one is 51. If I hit the enter button, it automatically moves to the second one and highlights it. So then I had 56, 57, then 52, 53, and so on. Take a few minutes to go ahead and enter in all your data. You are going to run out of the number values after 17, but again, we're ignoring this entire first column. You do not need to fill it in. Desmos will take up to 50 different data points, and we only need 40. Let's fill in the data. You may have noticed as you were entering in the data that the Desmos was changing the picture of the histogram every time you did it. Now, our picture doesn't look quite like a histogram because we have spaces between some of our bars. This may be the way that, that Desmos is graphing it. In general, however, they will be connected. Now, after we're done producing this graph, if you were going to draw this by hand, you would not have these open spaces in between. Let's take a look at the next thing that we can control on this, and this will help us to get rid of those spaces. So now we're going to scroll down to the next part, which is the number of bins that I have. A bin represents each one of the bars. So the number of bins is the number of bars that you want to have. If you remember the data values that we used in our frequency distribution table, I used the ages 51 through 59, so I had 9 different data values. I would like to change the number of bins to 9, and that will close up my spaces. So let's scroll down again. I'm going to click on the slider. This is a slider bar, and I'm going to go until I reach B equals 9. Do you see how this closed up the spaces in between the bars? This is what the histogram looks like. You can also drag the picture around by clicking anywhere on the screen, holding down the left mouse key, and moving your cursor. Now on the next line down, you can change the color by clicking on this blue dot that you have here. If you click once, it's going to take the picture off, but don't worry, it's still there. Just click again and it will come back. To change the color, do a long click, which means hold down the left mouse key until the colors pop up. Then you can change it to whatever you would like it to be, and it will usually take it a little bit for it to show up. Now the last part that you see here, these are the formulas that are actually creating the histogram. Do not touch anything in line 9. If you want to look at them, you can open up that triangle by making it point down, and you'll see that it's looking for the minimum value and the maximum value, and it's computing the number of different widths that it wants to use for them, and this is basically how we have tricked Desmos into drawing a perfect histogram. Now, this is only going to be applicable if you have fewer than 50 data points, or up to 50. You can't use this for something that has 600 or 300. For that, you would definitely want to use Excel. Let's pause here and scroll down to the next part, which is going to be how to use your graphing calculator. If you have a graphing calculator, go ahead and get it out so we can take a look at how to produce the histogram on a graphing calculator. I have found a very straightforward, simple website of instructions with pictures to guide you through the process of creating a histogram on any TI-83 or TI-84 calculator. There's also a short video, and you can find many others available on YouTube. If you want to find one on YouTube for your particular calculator, just Google TI-84 histogram. However, the directions on this web page should work for any TI-83 or TI-84. Let's take a look at what that website looks like. I'm going to pull it down on the screen so that you can see it, and then I'm going to open it up. Here's what the web page looks like. And you can see that it does have down here at the bottom a YouTube video and another one for Vimeo, which I'm not sure what that is. I generally use YouTube if I need something. You're going to go to your graphing calculator, and the first thing you're going to do is you're going to turn the stat plots on and select the histogram icon. You can see here that they have a picture telling you which one to do first, then second, then third, then fourth. They've circled the buttons and they've numbered them so you know the order in which to do them. So in this case, go ahead and turn on your calculator. Go to the second stat plot, which is going to be to hit the second button and then the Y equals button, and it will pop up a menu. The first one probably says 1 plot, plot 2, or so forth. Let me show you what my graphing calculator looks like as we go through this. I'll turn on the screen overhead. My computer or calculator looks slightly different than the one you see in the picture here when I got to the stat plot menu. You can see that I have a plot 1, plot 2, plot 3, plot 4, and so forth. Yours probably currently says off. Mine says on because I've already tried it. In any case, you want to hit enter so that you can get to it. Once you get to this screen, it will match the picture that you see over here on the notes or on the website for using the TI-83 calculator. You want to make sure that this first on here is dark. If it is not dark and the off is next to it is dark, put the cursor on top of on and then hit enter. That will make it dark. This is going to be the third thing you do. The fourth thing you do is going to be to come over here to what looks like a histogram, which will be in the top row. So you'll use your cursor keys. You can come down and scroll up, scroll to the right. Once it's on top of what looks like boxes next to each other, hit enter. That will turn it on. Now I want to scroll down to the next page, which is I need to enter my data values. So I'm going to go to the stat button and I'm going to edit. So the stat button is sort of in the center towards the top. So I hit stat. It automatically puts me on the edit menu. So I'm going to hit enter. And once I get there, you may have data values in the lists already. If you have data values in the lists, use your cursor key, and I'll show you on L2. Let me put some values into L2. I want to clear these out. To clear them out, scroll all the way to the top to highlight L2, hit the clear button. You'll see that L2 now says L2 equals blank, but it still shows the 5 and 8 I put in there. but once I use the cursor to go back down, they're now gone. Once I have that, all the other lists zeroed out, I'm going to use just L1. Go ahead and take a few minutes to enter the 40 values for our previous example of the Execucorps volunteers into L1. To enter a number, you just put in 51 and then hit enter, or you can use the scroll key to scroll down. So I could have done 56 and then scroll down, and that will replace it in there as well. Go ahead and take a few minutes to get those input. Before going on to step 4 on the website, we may want to check and make sure that we didn't accidentally leave any other functions in our y equals window. Let's click on y equals and see if we have anything there. You'll notice at the top that plot 1 is dark because I'm going to do a statistical plot. All of my y1, y2, y3, and so forth are blank. If yours are not blank, then you need to either clear them or you can turn them off by highlighting the equals and hitting the enter. If you do that, it will disappear. So let me show you what I mean. If I had x plus 2, right now the graph of the line y equals x plus 2 will show up on top of my histogram, which I don't want. I can either hit the clear button to wipe it out, or I can scroll over to the equals and hit enter, and that will turn the equal sign from dark to light, and now it will not show up on the picture. Going on to step 4, I'm going to hit zoom stat or zoom statistics. I hit the zoom button, which is at the top center, and I'm going to choose option number 9, or you can use the scroll key to scroll up or down until you see zoom stat. Hit enter. This is going to create the histograms. Now, if we go on to the next button, you can see that you can use the trace button to go between the different bars. So if I hit the trace button, it will bring up the minimum value and the maximum value for that particular box. And then as I scroll across, it gives me the min value and max value for each box. But for me, what's more important is it gives me the frequency. N equal 5 for the third box. I have 5 people age 53, 8 people age 55, and so on. This gives me a way of going back and forth. Now I can change the way the bins look by going into the window and changing the X scale if you want to do that. And it will show the bins looking slightly taller, slightly shorter, and so on. This is how you will produce a histogram using your graphing calculator. Again, it can be done either way. Either using Desmos or using the graphing calculator, but neither of those is ideal for large data sets. Let's take a look at using Excel. Excel is an outstanding way to produce a histogram, but there are more steps to it and it's a little more complicated. Excel is the program that we used for looking at mortgages and amortization tables. So you should have Excel available if you have the Microsoft Office suite on your computer. Excel, PowerPoint, and Word are the 3 programs that are always loaded with Microsoft Office suite. Looking at Excel, what you will need to do is install what's called the data pack, the analysis tool pack. If it's not loaded, it won't work. So in order to do that, there is a video that Professor Casabona has created for you, and you can watch it. It's about 1.5 minutes, and the link for it is right here in the center part. I'll walk you through what it looks like to open it, but if you need more help, you should watch the video. She also has a 6-minute video on how to produce a histogram using Excel. But again, this is created for the statistics class, and it does go a little fast, so I will work through it as well. Here in the notes, you have step-by-step what to do in order to do it, and also pictures of what it should look like. Let's pause while you go open up Excel, and we'll get your data pack loaded. You should now have Excel open on your computer. At the bottom, you'll see that there can be different sheets available. Right now, you should probably only have one sheet, but I've already created some things in here to help us, and that's why you see 3 sheets at the bottom. Histogram for problem 6, sheet 1, and sheet 2. We're going to start with sheet 2 just so that you can see what the steps would look like if you were starting from scratch. First thing we need to do is make sure the tool pack is installed. So you're going to come to the top. Let's make this slightly larger so that you can see it a little better. You're going to come to the top of the ribbon where it says Data. Click on Data. Now you're going to scroll to the right and you're going to look for something that says Data Analysis. So now what we're looking for is the Data Analysis. I don't see anything up here that says Data Analysis. I have Get and Transform Data, Queries by Connections, Sort and Filter, Data Tools, Forecast, and Outline. But I don't see Data Analysis. In order to find Data Analysis, I need to click the File tab. We can click this box off by just saying we've got it. So now click on the File tab. Scroll down to the bottom where it says Options, click on Options, and wait for a few minutes. Then it will pop up another window, and we're looking for Add-ins, which is right here. We're going to click on Add-ins, and then once it brings up the next box, we're going to be looking for something that says Manage. Next to Manage, we want to make sure it says Excel Add-ins. The Manage box is all the way down towards the bottom, and you can see it says Excel Add-ins. There is a drop-down menu for other kinds of add-ins, but the ones we want are Excel add-ins. Make sure next to Manage it has Excel add-ins, then click the Go to its right. The next thing is it's going to bring up a window with 4 different things you can add. We want the very first one that says Analysis Tool Pack, not the one that says Analysis Tool Pack VBA. So I'm going to click the box for Analysis Tool Pack, and then next to it I'll click OK. Give it a few minutes to get the tool pack installed, and now you'll see that if you're clicked on Data in the top ribbon, at the far right you have a new spot that says Data Analysis. You should now have the Analysis Tool Pack installed into Excel so that you can create histograms, find standard deviations, and find z-scores. At this point, we need to enter our data values into a column on the Excel spreadsheet over here. Take a few minutes to enter all the data values that we had in problem number 6 into column A. You can start in any spot you want, but it would make sense to start in A1, but again, it makes absolutely no difference. Enter all your data values into a column. For example, you can click in the A column, row 1, and you can enter 51. If you hit the Enter key, it will automatically go to the next row down where you enter 56, then 57, and so on. Take a few minutes to get all 40 data values entered in here. Once you get all of your data values into column 1, and if we have very long data sets, I will give you the data set so that it will already be created for you. We need to decide what our minimum and maximum are so that we know how we want to divide up our bars or our bins. So the first thing I would do is to pick a different column and type the word minimum. I'm going to be looking for the minimum and the maximum. It doesn't matter where you are, but it makes sense to move over slightly to the side. So I'm going to type in minimum, and then I'm going to hit the Tab key on my computer. This will move me to the right instead of down if I hit Enter. To get the minimum, looking at the notes, you'll see that up here there's a box. Next to the box that has the cursive F and X, you want to type in equals and then min. The minimum command will automatically pop up. You'll need to open the parentheses, and now we want to tell it that we want the minimum of our data values. You could type in their locations from A1 to A40, or you can move your cursor. You can use the left mouse key to click on the 51, hold down the mouse key, and drag until you reach the end of your data set. And this gives you from A1 to A40. And you'll notice that when I clicked and dragged, it automatically entered those values in. Closing up the parentheses, and now hit enter. When I do that, you'll notice that right next to the word minimum popped up 51. That's the minimum data value out of the 40 data values that we have. Now let's find our maximum. So again, looking at the notes, we're going to repeat steps 3 through 5, but using the max command. So I'm going to type in maximum so I know what I'm getting. Then I'm going to move my cursor up to the box next to the cursive FX. I'm going to type in equals max, M-A-X, open parentheses, use my cursor to left click on the first data, scroll all the way down to the last data value, and let go. Then I can type in a close parentheses and hit enter. This is going to give me my maximum data value of 59. This way, you don't have to hunt and peck through all the data values to find your minimum and your maximum. You could do that for 40 values, but not for 400. I'm going to go ahead and use the data values of 51, 52, 53, 54, and so on up to 59 as my different bin numbers. Doing this is what lets you decide how to break it up if you need a range. Since our ages were only given in whole years, I don't need continuous data ranges, but sometimes you will. So now we're going to scroll down in the notes to step 7. We've decided how we're going to divide up our data into basically each data value. In order to do that, you will want to be thinking about, is the data continuous or is it discrete? So in our case, it is continuous age, but the ages were only given as discrete values in terms of the whole year, not parts of a year. So I'm going to use my ranges as 51, 52, and so forth. Since I'm considering them to be like discrete, then that age becomes both the lowest and high value in that bar, so like 52 to 52. If they were continuous, if I were allowing people to be 52 and a half years old, then I would want to use ranges more like 50 to 55. And again, you'd have to decide, does 55 belong to 50 to 55, or does 55 belong to 55 to 60? And you can use the plus minus mark to help you remember that when you write it down. What I'm going to do is I'm going to move to a blank column and I'm going to enter my lower data range values and my upper data range values. For this particular example, my upper and lower are the same because I'm not allowing ranges. So I'm going to enter 51 and then 52, 53, 54, 55, 56, 57, 58, and 59. So that when I'm done, I should have 9 separate bars in the histogram, or 9 bins. Up above it, I could label these and I could call these lower for the lower values. And if I tab to the right, I can put in upper. Now you could re-enter the data, or you can left click on the top one, drag the cursor till you highlight all of them, hit Control C or Command C on a Mac, put your cursor in the first spot where you want it, and paste the results in. Now if you click somewhere else, then you've got both your lower and upper, which mine are the same. If I were using a data range like 50 to 55, my lowers would be 50, 55, 60, 65, and so on. And the uppers would be the upper values. Now, what we want to do now is we want to tell the computer how to compute the histogram. We're going to click on the Data tab up at the top in the ribbon, scroll over to Data Analysis. We're going to click on Data Analysis, and after we click on Data Analysis, we should get a window that pops up. We'll give Excel a few minutes to decide it wants to open our window. There's our window, which we can drag it up here so you can see it a little better. You can see that there are various options that you have in here. Later we may be using the z-test, and we may also be looking at a few other things such as descriptive statistics, but right now what we want is the histogram. So what we're going to do now is we're going to select the histogram by clicking on it, and then we're going to click OK. Once it goes to that, it will pop up a new window. At this point, you should be on the left-hand side in the notes, you should be on step 12. On step 12, what we want to do first is click in the first open square, which you'll see is where it automatically puts you. This is the data values that you want to input here. So for my data values, what I can do instead of entering it as A1 to A40 is I can just click in the box to make sure I'm there, and then I can go over here to my screen. I can click on the data values, scroll all the way down to select all my data values, and let go. That will automatically put the locations of the data values into the input range in the order and in the formula that Excel needs them to do it. Bin range. What is the bin range? For bin range, what we want to do is we want to look at the upper data values. Now for us, our upper data values ended up being the same as our lower data values because I'm using these as if they were discrete data. So I'm going to make sure I'm in bin range by clicking in that open box, click on the 51, scroll to 59, and let go. That automatically inserts those values as the upper values on each of my ranges. Notice it does not ask for the lowers, just the uppers. The next thing you need to do is going to bring us to step number 14. 14 is asking where we want to put the histogram. Now, if you're on output range, you could superimpose the histogram right here on top of your data, where it's just sort of like a floating sheet of paper that you put on top of another piece of paper. Usually for most students, though, it's easier to put it on a different sheet as if it were on a different sheet of paper. That's the default choice, which is New Worksheet Ply. Ply meaning piece of paper. So we're going to put it on a new worksheet ply, but we're going to give it a name. So this one we're going to do video example is what I'm going to name it. So I have video example as going to be the name of the new sheet, and it will show up down here at the bottom. Before you get off of this window and click OK, you must be sure that you click Chart Output. If you don't click Chart Output, you won't get the output, which is the histogram, which was the whole reason you were trying to do this. So make sure you click that before you go on. Now click OK. When you click OK, it's going to automatically open that new sheet, and you'll see the name of it down here at the bottom, video example. On the left side, you'll see an actual frequency distribution table. The bins are the values that we used, and the frequency is the number of times they showed up. So you could actually produce a frequency table by producing a histogram using Excel. Now on the right, you'll see my histogram. This is something that is draggable, meaning if I wanted to, I could click on it and I could drag it around the page. That's what I mean by like a floating sheet of paper on top of everything else. Do you see how it covers up the frequency distribution table? I'm going to move it back over to get it out of the way. And let's talk about this histogram. The histogram does not look like a histogram because the bars aren't touching. The default in Excel is to produce a bar graph. To get it to look like a histogram, we'll need to do a little bit of work. However, before we start, you can actually click inside on top of the labels and you can change some of these. If I don't want to call this histogram, I could call it video example histogram or something else. So video example histogram is going to be my label. At the bottom where it says bin, I could change that and make that ages of executives or executive volunteers. That makes it a little bit more descriptive of what I have. The one on the side, which is frequency, is going to stay the same, though technically you can also change that as well. You'll see on the right that it's telling you in a legend that the blue marks the frequency with which they occurred. Now, if you want to make it bigger, you can pull on the corner of it, and that will make the whole thing larger so that you can play with it a little more. You can always move it off of the frequency diagram by moving it to the right. The problem that I have now is it doesn't look like a histogram, it's a bar graph. So what I want to do is I need to click on some commands to get it converted. Click on the chart until you see the rectangle with the empty circles around the edges of the circle. Once you see that, then you're going to go up to the top ribbon and you're going to click on Design. When you click on Design, it will change the ribbon options down here. We would then want to move over to what's called Quick Layout, which is on the left side. On Quick Layout, there's a drop-down menu which gives us 8 or 9 or 10 different options. The one we want is the one that the bars are touching that looks like a histogram, which is layout number 8. If I click on layout number 8, it will change my bar graph into a histogram, and the bars will be touching. That's basically all you need to do to produce a histogram using Excel. Now, the nice part about creating a histogram with Excel is that it is something that you can import into Word. So for example, provided you click on the box so that it's highlighted in this rectangle with the open circles around the edge, you can do a copy command and open up a Word document, and it will paste directly into the Word document. Let's try pasting this histogram into our notes. I have it highlighted. I'm going to hit Control-C since I'm on a Windows computer. If you're not on a Windows computer, make sure that you use Command-C for a Macintosh. I'm going to go over to my page of notes, and I'm going to do either Control-V for a Windows or Command-V for a Mac, and you'll see that it pasted that picture directly in there. And once it's in there, I still have the ability to control some of the things. I can change the size. I could change the color of it if I don't like the color. I can make my color some different color. Whatever I want to do to it. Let's say I want to make it green. I can make it green, or I can make it red. I can do various things. I can also even change the colors if I don't like the colors it's giving me. I can come in here, I can print some data labels, I can do a data table at the bottom to see the actual frequency table. We don't need the error bars, but there are also grid lines I can produce. I think grid lines is probably worth doing. I can change the legend or the trend line if I want to look at the trend line. There's all kinds of things I can do even after I've pasted it into Word. In that sense, I would say the Excel is probably one of the most versatile and widely used ways of producing graphs. Again, to get those choices, click on the picture and that will pop these choices up over here. Chart filters enables you to change some of the data points and the names that are visible. Now let's take a look at interpreting some of the histograms that are in the book. So we'll take a look at problem number 14 and 16, which is interpreting the data presented in a histogram. So in problem 14, we can see that we have a histogram here in the center of the page, and this is about a campus rec center that is surveying the number of students using the center hourly between 9 p.m. and midnight for a semester to decide if it should reduce its hours. So in other words, for one semester, they looked to see how many students were in there at night between 9 p.m. and midnight. So we had, for example, how many times were there no students in the rec center between 9 and midnight? It looks like the height here is 7, so there were 7 occasions in the semester when there was no one in there to use the rec center. How often were there exactly 3 students in the rec center between 9 and midnight? Well, that never happened, nor were there ever 10. but there were 2 occasions when there were 12 students in there between 9 and midnight. Now let's take a look at the questions down below. Down below it says, what is the smallest number of students in the rec center? And how many times did it occur? Well, if we're going to take a look at the smallest number of students in the rec center, then you have to admit that it's pretty hard to be smaller than 0. There were 2 occasions when there were 0 students in there. Now, that gives us the number of 0 being the smallest number, and how many times did that occur? So we would say that there were 0 students in the rec center, and it occurred 7 times because over here, the horizontal axis represents number of students. We had 0 students on 7 different occasions. 0 students occurred 7 times, and that would be our solution for that one. What about the next question that we have below that? If we're looking at the next question below that, it says, what was the smallest student count between 5 and 8 inclusive? How many times did that occur? Between 5 and 8 inclusive means that if you're looking at the histogram, they want to only look at the bars for 5, 6, 7, and 8. Inclusive means include bar for 5 and include the bar for 8. If we look at the heights of these 4 bars, which one is the lowest? The lowest is the one for 7 students. So the smallest student count between 5 and 8 inclusive was 7, and that occurred how many times? Scrolling across, it occurred 7 times. 7 students, which occurred 7 times. Let's take a look at the next question. Question C, for how many hours was the survey taken? The horizontal axis is the number of students, so the frequency represents the number of hours in which it was taken. So to do that, we need to add up all of the frequencies that occurred on the histogram. So for that, what we're going to do is we're going to add up the frequency of 0, which would be 7, plus the next one would be 8, plus the next one looks like 5, plus 0, plus the next one is 3, plus 8, plus 10, plus a 7, plus a 9, plus 5, plus 0, plus 3, plus 2. These represent the number of hours because these are the heights of the boxes. This is the number of hours or the number of times that the survey was done. So if you add all of those together, you should come up with 67 different hours. The final question is, for what fractional part of the total number of hours were fewer than 5 students present? Fewer than 5 students means I can't have 5 students, so I'm looking at the bars for 4, 3, 2, 1, and 0. So I would add together those values. Let's take a look at what those would be. So scrolling down just a little so I can see them all. On the next line down, I may have to move this up a little bit. It looks like I should have down here, if I start at the 0, I had 7 times I had no students, so 7 plus, and 8 times I had 1 student present, plus, I had 5 times with 2 students present, 0 times did I have 3 students, and 3 times I had 4 students. If I add those numbers together and then I divide that by 67, that will give me the fraction of the total number of hours that I had fewer than 5 students present. If I do the division, this ends up being 23 divided by 67. Let's take a look at the next problem that we have to do. This is a bar chart and not a histogram because you can see that they're not connected. This has to do with the living arrangement of U.S. adults. If you look in the legend, you'll see that the blue bars represent the year 1990 and the orange bars represent the year 2000. This is the percent of people who are living alone, living with a spouse, child of the householder, living with a partner, or some other living arrangement. So for example, if we're looking at the year 1990 and we're looking at living alone, there were 12.8% of people in 1990 lived alone. In 2000, it was 13.3%. Let's use this information to compute the next part in question number 16. In question 16, they want us to use the percent of change formula from Chapter 8, which again is the new amount minus the base amount divided by the base amount, to determine which type of living arrangement had the highest percentage of change. In order to do this, I'm going to shrink the page so we can see it all at once. In order to complete question 16, I've created a table here to organize our information by the data values, living alone, living with spouse, child of householder, etc., and the years, and then I've created a column for the percent change. Our base year will be 1990. So we're going to start and we're going to enter our data into the columns right here. And I'm going to put these in and make sure that they are in the center. In 1990, how many people were living alone? What percentage? 12.8. Use the cursor key to move down. In 1990, looking only at the blue, what percent of people lived with a spouse? 58.5. Take some time to go ahead and complete the second and third columns on your notes, and then we'll complete column 4 together. Now that we've completed columns 2 and 3 with our data from the bar graph, we're going to compute the percent change. I'm going to put the numerator in parentheses so that I divide the whole thing by the base amount, which is from year 1990. My new amount is 13.3, and I'm subtracting from it the 12.8, and then I'm going to divide that by 12.8. And when I'm done, you will have about 0.039. Or my percent change is about 3.9%. That's about the percent change between the year 1990 and 2000. Because it's positive, it means I have more people living alone in 2000 than I had in 1990. Take a few minutes to pause the video and complete the rest of column 4 on your own, then turn it back on to see if your values are correct. I've completed column 4. Check your values to make sure they match up with mine. In the year 2000, we have 56% living with a spouse compared with 58.5% in 1990, which means we had a decrease of negative 4.3% of people living in that arrangement. This is the end of what we're going to cover out of section 14.1. We are skipping the stem and leaf displays. I hope that you've enjoyed doing this, and I hope that you will play around with using Excel and the graphing calculator in Desmos to produce histograms. Your final part of exam 4 will be producing histograms on one of these methods and either drawing it by hand or producing it using one of these others. I recommend using Excel as I think it's the simplest one to do. This concludes this video. Make sure that you submit the quiz before you close it out, or I won't be able to re-get the grade.